Okay, again, good afternoon to all of you. And I am really grateful to the Mathematics Department or Royal Global University for giving me an opportunity to deliver a talk. And thank you all. Actually, what happens nowadays, as far as the new education policy 2020 is concerned, that our teaching, research, extension work, community work, everything goes in a multidisciplinary concept, interdisciplinary concept, co-disciplinary concept, and so on here. First thing is that mathematics, without mathematics, no knowledge, any knowledge in any field cannot be developed. Whether it is a social science, or commerce, or law, or medical, or engineering, or any basic science, physics, chemistry, bioscience, biotechnology, mathematics, and without sophisticated mathematics, we cannot develop, we cannot discuss in a very sophisticated way. And with this idea, with a very little knowledge or very limited knowledge, and let us have how with the help of the mathematics, we can study a lot of other things. Say for example, nowadays, just for the cancer disease. Cancer disease is a very alarming, it creates a very alarming situation in the whole northeastern region, in Assam as well, and all over the world as well also. And as far as the Assam state is concerned, as you know that several thousand people every year suffer from the cancer. And out of the several thousand people, at least 6,000 or 7,000 people, cancer patients die every year, even in Assam. And therefore, in that case, what kind of mathematics we can use to study the cancer diseases? And that is my initial echo. And I think that our students also must be engaged in the multidisciplinary research or interdisciplinary research. And this will give some sort of ideas and some inspirations to our students as well. And then, okay, let us go to that. As far as the mathematics, okay, as far as the mathematics modeling is concerned, then you see that mathematics modeling, it is not working anyway, that mathematics modeling refers to the process of creating a mathematical representation of a real world scenario or issue to make a prediction or provide insight. It allows better design, control of a system, and the efficient use of modern computing capabilities. Mathematical model can take many forms, including dynamical system, statistical model, differential equation, game theoretic method, and so on here. And components of a mathematical model, as you know, are variables or decision parameters, say constraint, calibration parameter, input parameters, data, phase parameters, output parameters, noise, and random parameters, and so on here. Okay? And engineering and scientists use technology of mathematical modeling and design future technology. In engineering and technology, it provides the analytical basis for design and control in which prediction can be confidently made. But as you know that, for example, say differential equation or delay differential equations, or suppose now the stochastic differential equation and stochastic analysis, they are the fundamental pillar of all science and technology nowadays. And in this regard, mathematical modeling, chaos theory, nonlinear analysis play very vital role. And therefore, I am not a biologist. I cannot give basic idea of the biologist. And so far I know that cancer is a life-threatening disease in which some body cells grow uncontrollably and in some cases spread and invade organs in other parts of the body, a process known as the metastasis. India has around 2.25 million cases, with over 1 lakh new cases being registered every year according to the Cancer India organization. A scientific paper published in the American Cancer Society journal CA, a cancer journal for clinicians reports that an estimated 1.9 million new cancer cases were diagnosed and 685,070 cancer deaths in the United States in 2021. Even you say that the USA is a very advanced country, but still every year more than 6 lakh cancer patients die even in USA. And it is a very alarming situation if in northeastern region and Assam is concerned here. And so I know with a little knowledge what will happen is that our whole body is composed of million and cells. Cell is the fundamental unit of our human life. And originally the stem cells comes. And stem cells just like a foundation of the human life. It is just like a foundation. And different cells, there are 200, I think more than 200 different kinds of cells. And cells in our body just like they are the bricks of the building. In the bricks of the building, the foundation is there. The foundation is the stem cell. And stem cells has some subdivision that we call the daughter cell. And other cells, they are utilizing just like a bricks of the whole body here. Our whole body is composed of the cells. Okay, all the cells. And what will happen is that these cells move in a cyclic order. They move in a cyclic order. First is the G1. That means cell according to the DNA system. DNA works just like a computer algorithm in our human body. And DNA gives the signal at what time the cell should grow, at what time should activate, at what time it should die, at what time it should give the subdivision. That means new development of the cells and so on here, DNA. And normally it moves in a cyclic order. The G1 is the initial growth of the cell, and S is the DNA synthesis, DNA working in a very nice algorithm type, okay, as per the signal. What kind of signal processing is used, what type of communication network is using by DNA, and that can be also represented by very suitable mathematical equation. That is the important thing as far as the human biology is concerned here. And next is the G2 stage, growth and preparation for the mitosis. And that is what is developed, and they prepared in the third stage for the development of the new cells here. And then M is the mitosis, that the cell division is growing on as per needs of our body. Cells go on and protect the normal life and the human life. Okay, and that is cells play very important role. And it activates, it's generated by the DNA synthesis. But sometimes what happens that some cells do not obey the instructions or suppose directions of the DNA, sometimes it happens. And then what happens, some cells start growing themselves without the observing, without the instruction or without disobeying the instructions of the DNA here. They start their own way. And that we call the abnormal cell in the human life. That we call the abnormal cell. And ultimately the abnormal cell converted to the cancer cell. And initially what happens that if it's at the initial stage of the cell, it takes, because it needs also blood circulation, it needs also some sort of directions and some sort of direction of some sort of process so that it can grow also on its own. Initially, they take the blood from the nearby blood circle, near the tissue, and then when it becomes bigger and bigger, in that case, the normal blood cells, they cannot provide sufficient blood to the cancer cell, and they develop their own blood systems, and they develop their own DNA system, just like a terrorist group in our country, in our state. And terrorist group, they want to destroy the human civilization and something like this. And they want to develop on their own way. Their director is, their commander is something like this. And just like in our human body also, the cancer cells just acting just like a terrorist. They want to attack the health. They want to destroy the normal systems of the health here. And there are 4 stages of the cancer. The first cell is there. And then what will happen is that When in the second stage they start growing and they do not obey the instruction of the normal DNA, and then when it gets bigger and bigger in the stage, they develop their own blood circulation, develop their own DNA system, how they can develop or something like this, how they attack the different immune cell, normal cells, and so on here, and develop this way. And after that, what will happen is that they invade the whole body. By the blood circulation, by the blood vessels, they try to move from one part to the other part of the body, and they develop their own, their activities in different parts of the body. And when they become very active in the different part of the body, and that is called and in that case, what is in the fourth stage, when everything becomes independent, that is the fourth stage of the cancer, and become insidious here. Actually, what is meant by the cancer? How the cancer develop in a body? Let us have I think just a 2 minutes video. Let us hear from an expert. They say, what is the cancer? How it develops in our body, and so on here.
One out of every 2 men and 1 out of every 3 women will be diagnosed with cancer. But despite those huge numbers, most individuals don't know what that really means. At the simplest level, cancer or cancer cells are cells that have lost the ability to follow the normal control that the body exerts on all cells. In our body, we have billions and billions of cells, and they have different functions. It's a very complicated process under incredibly phenomenal control. And if something goes wrong and that control is lost, then particular cells escape the normal control mechanisms, and they continue to grow, and they may spread. That's what we call cancer. Those cells together, we would call that a tumor. Specifically, cancer is a malignant tumor, and we call it malignant because not only can it invade into adjacent organs, but unfortunately, cancer can spread to other tissues, and that can be life-threatening. Cancer can actually occur anywhere in the body because there are cells everywhere in the body. In women, one of the most common cancers, of course, is breast cancer, and in men, prostate cancer. And in both men and women, lung cancer and colon cancer are common cancers. It's important to understand that the cancer that occurs in one individual is very different than the cancer that occurs in another, just like those individuals are different. So a lung tumor in one person will be very different from a lung tumor in another person. Once the diagnosis of cancer is made, of course, the next obvious question is, what do you do? There are several things that are really relevant to the stage of the cancer, which is information about where is the cancer. You say it's a particular kind of cancer, how much cancer is present, has it spread, is it in lymph nodes, has it spread to other organs of the body? Cancer treatment actually is very complex. And part of the reason is because cancer is this constellation of over 200 different diseases. They have common characteristics, but they're all very different from each other. In addition to that, the cancer itself is not homogeneous. There may be 3 or 4 or 5 or 6 different slight variations in the cancer cells that are there. People ask, why? Why does some cancer not go away? It shrunk by 70%. What's wrong with the other 30%? Well, it's probably...
What happens that before starting or working some mathematical modeling on the cancer disease, and everybody should have some basic knowledge. One is the bioscience, biotechnology, and another thing is that what is the human biology, what is the molecular biology, and how it is related to the signal processing communication of what. Some concepts come from the physics. And as far as our body is concerned, the whole biological structure, there are a lot of chemical reactions, chemical equations, proton, electron, neutron, and you should have some knowledge of the chemistry as well. And it is the very multidisciplinary concepts comes together to study this kind of research or this kind of problem here. Then what will happen is that when the cancer starts, up to some levels, our immunity cells or normal cells attack the cancer cell, and the cancer patients can be cured, no problem. But after some stage, cancer cells overcomes, they defeated the immune cells, normal cells, everything, all cells, and our activity stop, normal activity stop. And in that case, we need some sort of, suppose, medical or cancer treatment. And suppose when a cancer patient is admitted, then doctor immediately start radiations, if it is a localized radiations, and after that, if possible, some sort of surgery. Because of surgery, it can be removed of the unwanted cell or unwanted sufficient, that is problem, some area of the body. And after that, still, when all these are fails, when the cancer spread all over the body, and it becomes very activated in every part, our normal functioning stop. As in that case, doctors prescribe some medicine, chemotherapy, phytotherapy, or immunity therapy, and there are a lot of therapy and a combination of this. And normally, as far as India is concerned or Assam is concerned, and chemotherapy, this phytotherapy and community immune therapy, all these sophisticated methods are not utilized. Our doctor cannot do that in India. In advanced country, they can do that. That chemotherapy start. And when chemotherapy start, then what will happen is that actually some expert surgeon will come and examine the patient. Okay, you give the 4 doses of the chemotherapy. So you start from this, and then you give, suppose 7 days or 3 days gap for the development of the immune cell and normal cell, something like this. And after, suppose 3 days or 7 days, you give the second chemotherapy. But normally, what is the drawback here? Chemotherapy has a lot of side effects as well. In addition to the killing the cancer cell, it kills the normal cell, immune cell, and other cells as well. And as a whole, our body becomes very weak. There are a lot of problems of the, suppose, the loss of the hairs. Our immunity systems is reducing here. And then in that case, loss of the appetite, loss of the kidney problem, lot of the heart problem, lots of the, suppose, liver problem, other problems, side effects come. But with this lot of side effect, when the second dose of chemotherapy is induced or injected through the body, whether the body of the patient can accept second dose or not, and our doctor, because they do not apply the computer technology so much or the mathematical formula, something like this, they push the same amount of chemotherapy, and in that case, health becomes again more worsened. The patient becomes very, suppose, very weak in that case. Because the surgeon has prescribed that you give the 4 doses after interval of 7 days or something like this. And according to the suggestion, direction of the surgeons, and the junior doctors inject the chemotherapy. And when the chemotherapy, the 3rd dose started injected into the body, whether body can accept or not, whether body has the capacity to accept it, it is very strong medicines. And it will fight against the cancer, disease of cancer, okay, viruses and something like this. And then in most of the cases, you will see that when the 3rd dose inject or the 4th dose injected, many patients cannot accept the 3rd dose and 4th dose, and as a result, the patients die. And therefore, what is the objective of the mathematics then? Okay, what is the objective of the mathematics? Mathematics says that when you impose the first chemotherapy, and what will be the amount of the second dose, you may have some mathematical formula, some calculation of these, and what will be the shortest time so that it cannot have so many side effects, and how determine the time, whether it is 3 days or 7 days or 8 days or maybe 1 day. And in a shorter period, and how you can reduce the amount of dose. And these are the study of the mathematics things, okay, mathematics things. And then you see that when you inject the chemotherapy, it kills the cancer cells, no doubt, but at the same time, how it will affect our normal system of the body. Let us have a suppose 1 or 2 minutes video, and it will give a lot of inspiration how the chemotherapy has the side effect as well.
If you have cancer, your doctor may recommend chemotherapy as part of your treatment. The cells in your body grow and divide as part of the normal cell cycle. The cell's nucleus controls this process. Inside each nucleus, genetic material called DNA contains the instructions for directing this process. Sometimes the cell's DNA becomes damaged. Normally, the DNA responds by either repairing itself or instructing the cell to die. In cancer, however, the parts of the cell's DNA that direct cell division become damaged. When these sections are damaged, the DNA is unable to repair itself or cause the cell to die. Instead, the unrepaired DNA causes the cell to grow and divide uncontrollably into more damaged cells called cancer cells. A tumor forms as the cancer cells multiply and displace the normal cells.
The blacks are the cancer cells. All the blacks are the cancer cells.
As the tumor enlarges, it develops its own blood supply. Since cancer cells do not stick together as well as normal cells, they may break away and enter a nearby blood vessel. Cancer cells in blood vessels may travel to other areas of your body and form additional tumors. This is called metastasis. Additional tumors may form in areas such as the lungs, liver, and bones. Another way cancer may spread to other areas of your body is through your lymphatic system. Cancer cells may enter lymph vessels near the tumor, then travel to small glands called lymph nodes.
So the blood vessel is moving from one part to the another
If the
part.
cells pass through the nodes, they may continue to travel through your lymphatic system and form additional tumors. Chemotherapy drugs work by targeting fast-growing and reproducing cells, a characteristic common to cancer cells. The tumor shrinks as the cells stop dividing and die. Most chemotherapy drugs work systemically as they travel throughout your body in your bloodstream. As they circulate, the drugs damage metastatic cancer cells in other organs. Unfortunately, chemotherapy drugs cannot tell the difference between fast-growing normal cells and cancer cells. As a result, these drugs also damage or irritate some of your fast-growing normal cells, such as those in your bone marrow, digestive system, and hair follicles.
And therefore, actually, what happens that one of the advantage of the chemotherapy is that when a chemotherapy injection by tablet or injection is induced in our body, and then the chemotherapy, the drugs, they try to find out what is the cancer cell is, they just spread the whole body and try to kill the cancer, suppose cells as many as they can. But at the same time, the chemotherapy cannot identify the difference between the normal cell, immune cell, other cells chemotherapy, and at the same time, they kill the immune cells and normal cells as well. And as a result, there are a lot of problem of the health problem here because it destroys the normal systems of the whole body, okay, as a whole. And therefore, it kills the cancer cell, but at the same time, it has a lot of side effect as well. And that is also very much described by it is that lady is the UK surgeon, and the first video is the some American expert. As you know that UK cancer organizations and American cancer organization, very strong organization in studying the cancer problem, cancer disease, and so on here. And therefore, on the basis of this, suppose that the cancer biology and molecular biology, on the basis of that, on this idea, and then we need to construct, suppose let us have some discussion of the chemotherapy. And as far as the chemotherapy is concerned, that what kind of mathematical modeling is important and how you can compose the mathematical modeling. And that is a very challenging task. To compose, to construct the mathematical modeling, it is not a very easy thing. It is also very tough things. And after composing a suitable mathematical model, and then with the help of the very sophisticated formula of mathematical theory, we can study a lot of things. but initially how to compose a mathematical modeling, and that is, I think, very important, and that is very complicated as well. And simply let us have a discussion of the research problems of the one of the, suppose we consider that, suppose there are 4 variables, and we consider the 4 variable, the IT, that I is the number of immune cell, I represent the immune cell, and K represents the cancer cells, and H represents the normal cells, and C represents the what amount of the chemotherapy is induced to the body. Let us have the 4 variables here. And in the 4 variables, and then what will happen is that di dt equal to tau, we have gotten ordinary differential equation represent the 4 variables. And but how we can construct of this, okay? How we can construct of this? You will see that tau, rho, sigma, delta, gamma 1, mu 1, alpha 1, beta, gamma 2, gamma 3, mu 2, delta 2, H4. There are so many parameters are there. As far as the chemotherapy is concerned, we consider the 13 different parameters. We need to consider the 13 different parameters. And when you combine the pyrotherapy and chemotherapy, we need about 25 different parameters. The first observation is what will be the range of the parameters, how we can determine the range of the parameters, and that is a question of the data science now. Okay, machine learning, artificial intelligence based on the data science nowadays. And from using the lots of data, data science gives the tools, and they develop the method, and then related to the technology. How we can give the different method, how we can develop the tools, and how we can utilize the technology. And data science is the basis of determining the range of all these parameters here. And what will happen is that, initially consider that, and that at the initial point t equal to 0, I0 is positive, K0 also positive, H0 is positive, C0 also positive. We consider the initial values of this. In equation 2.1, the first term tau represents the constant source rate of measured immune cell. In our body, we need some measured cells, okay, and it starts growing, okay, in every second or every moment start growing. And that is the tau represents the constant source. And what is this tau? Tau represents the constant source rate of measured immune cell in the body. The tumor-specific immune response is regulated through the second term of the first equation, rho ik. When the cancer cells grow and they interact with the immune cells, okay? They try to, immune cell also fight with the cancer cell, and the cancer cells also fight with the immune cell. Cancer cell try to destroy the immune cell, and immune cell try to cancer the cancer cell. But still there is a lot of growing and the interaction. And the second term, rho ik sigma plus t, whether this term is suitable or not, okay, that is one of the interesting thing. And that concepts come from the Michaeli-Menton form. Michaeli-Menton form, it is sophisticated theory in the chemical reaction, in chemistry. And we mathematicians have borrowed that concept because it is a lot of interaction of the molecules inside the body here. And therefore, second terms, that in spite of the fighting, killing to each other, but still there is a growth, okay? There is a growth of the cancer cell and immune cell, and that can be regulated by this cell here, okay? This cell here. Okay, and that is one thing. Michaeli-Menton. Rho is the rate at which the immune cell grow. What is the rho? What is the rho here? What is the rho here? Immune cell has the natural growth rate, but when the cancer cell attack the immune cell, and then the growth rate become more and more. Okay, the immune cells try to grow more and more, so that it can attack effectively the cancer cell, and it can be regulated by this rho here. That parameter rho here. Rho is the rate at which the immune cell grow. Sigma represents the stiffness of the immune response. At what immune response it try to respond to kill the cancer cell. And the term delta to represent the natural mortality rate of the immune cell. This delta, immune cell also die. From time to time it die. At what rate it will die? And that is the delta 1. And gamma 1, okay, delta 1 represent this by parte interaction between the immune cell and tumor cell that live. And similarly, gamma 1, the interactions of the immune cell and cancer cell, what is the death rate, and when the chemotherapy is there, then the chemotherapy also destroys of the immune cell, and what is the rate at which the it kills, and then delta 1, gamma 1, mu 1, these parameters are this way. And therefore the first equation is constructed with this, suppose 1, 2, 3, 4, 5, 6 parameters, and it will give the different range of this. And exactly the dk dt also constructed by applying some sophisticated mathematical formula and so on here. And therefore at what rate immune cell grow, at what rate immune cell will be destroyed by the cancer cell, at what rate the normal cells grow, at what rate normal cell will be destroyed by the cancer cells, and all this regulated by sophisticated mathematics, okay, mathematical formula, and these are the, okay, we have constructed these things here. And then after composing the mathematical model, whether this mathematical can be applied in our human body or not. Because we can draw a lot of mathematical formula. And that's why before going to the mathematical calculation or mathematical study, and first what you saw there, okay, and that, okay, drug administers, okay, okay. What is the another problem is that, why chemotherapy cannot be very effective, because in the cancer cell, every cancer cell, in a normal cells, they make some tissue means it's a collection of the cell, and tissue work uniformly in an identified way to maintain the health. But as far as cancer cell is concerned, every cancer cell has their own biological property, with their own biological structures or something like this. Therefore, if the chemotherapy kills some cancer cell, it may not be able to kill some other cancer cell, because by biological structure, biological feasibility are completely different here. And moreover, if the chemotherapy works for a person, it may not work from the other person also, because human body biological structure from man to man is different, and cancer problem also man to man is different, and in that case also chemotherapy must work with a different individual. And these are the sum of the problem here, because if you see that the mathematical model formulated so far failed to explain also the genetic mutation that cancer cells develop over time causes serious resistance to a treatment over time, and so treatment becomes ineffective. Each broad cancer type has many subtypes with different characteristics, and so each cancer can be as diverse as people are. As you know that there are more than 200 different kinds of cancer nowadays. Every tumor has an individual set of mutations, and so a drug that works for one cancer patient might not help the other one as well. Okay? Cancer cells within a single tumor are not identical. Okay? Are not identical. And therefore, after that, what is our item is there? Okay, we consider that equations. Okay, because I do not want to explain so many things because it will take lots of time. And then first objective is, as per mathematics model is concerned, whether biologically this feasible or not, whether this kind of applied in our human biology or not. Okay, it must be feasible. And when you send a paper on this area or something like this, then bioscientists examine whether the model really can be applicable to the human body or not. They examine this. And therefore you to verify, you can show mathematically or our scientific argument that our model is really feasible for the human body. Okay? And therefore, before we proceed with the mathematical analysis, we need to show that the model which consider parameters, values is biologically feasible. Okay, must be biologically feasible. And then there is a sophisticated formula. What is that? The feasible region defined by, if you consider four variables, and four variables belong to the four-dimensional space. R plus means we consider the initial value greater than equal to 0. And then if the IT immune cell is less than equal to this, KT is less than equal to beta, ST less than equal to 1, CT less than equal to this, in that region, that means we consider a bounded region. It cannot have the infinite regions. Okay, it is a four-dimensional figure and it has the boundary of X, Y, Z or some four-dimensional space. And then we first verify that this results is what we consider that it is bounded by this, okay, bounded by this, As you know as a man of mathematics that where a sequence or series has the upper bound, it has the least upper bound as a least upper bound axis. Okay? Then first we verify and prove whether our equations is really satisfy this condition or not. Okay? They satisfy this condition or not. And this is one type of mathematics. I do not want to show the proof. Okay? We can prove by using some mathematics here. And then these are the sum of the calculations. And ultimately we have proved that yes, our domain is a positive invariant for the model and therefore biologically meaningful. Okay, biologically meaningful. First, we must prove that whether our model is biologically feasible or not. Okay, that is the first thing. And next, as usual, the mathematics, as far as the applied mathematics is considered here, and just we consider stability. That means equilibrium point. We consider equilibrium points. Under what condition this equilibrium point or critical point are stable, or what condition it will be unstable. How the unstable condition can be converted to stable condition. And that is our concept. We want to maintain a normal health. Normal health means now I am a normal human being. Then everything is an equilibrium point. Everything is worked in a very nice way. Okay? And that is the, okay, then what will happen there? Let us find the equilibrium point and their existence. If you go on this way, and then what will happen that the first equilibrium, there are two equilibrium points. The first equilibrium point is obtained as E1 equal to I1 0 HC1, which can be termed as the tumor equilibrium point. That means 0, that means first, second term equal to 0. Tumor equilibrium point, and this equilibrium point means that the system is tumor free, where I1 equal to this, K1 equal to this, H1 equal to this, C1 equal to this. We have got the two equilibrium points, and then the equilibrium point we see that the second term, the number of tumor cell equal to 0. Number of tumor cell is 0 does not mean that there is no tumor cell in our body. That means to some stage, the tumor cells can be controlled by our immune system, immune cell and normal cells. And in that case, since it's simply control, we can consider number of cancer cells. That means it can destroy that. To some extent, it can destroy. And the second equilibrium point, okay, I2, K2, S2, C2, which can be termed as the coexisting or unhealthy equilibrium point. What is unhealthy equilibrium point? In that case, cancer cell is there, okay? K2, the cancer cell is there. And the values of I2, S2, K2, and these are the calculations, okay? And the calculation seems to be very complicated of something like this. It is a very complicated calculation now. But at the same time, everybody has a good knowledge of the Mathematica or MATLAB or other computer software. By applying the other mathematical software or suppose Mathematica MATLAB, we can solve this equation very easily, okay? It takes time, but we can have the solution of this, okay? And these are the equilibrium point, and you consider the positive equal to this and this. And if you go on this way, these two equilibrium point, and then our next objective is the stability of the equilibrium point. How to discuss the stability? That means stability means under what condition the patient will be completely cured, and under what condition the patient cannot be cured. Okay, and under what condition medicine is necessary, and under what condition medicine is not necessary. And that is the idea of this here. And then what happens that in that case? In this case, we investigate the stability of each of the equilibrium points by linearizing the system. This is the process of the applied mathematics. A non-linear system we convert to the linear system to some extent, not all the time. And by applying the linear system, we consider which the equilibrium points either stable or unstable. Okay, what is the first stage? Without treatment case when Ct equal to 0. There are two cases. And suppose the chemotherapy is not necessary, but any kind of suppose treatment is not necessary. In that case, under what condition, it will be the stable. Stable means the patient will be completely cured. Under what condition? Suppose you consider Ct equal to 0. In this section, we study the nature of stability of the equilibrium points E1 and E2 by considering Ct equal to 0, and that is before employing the chemotherapy for treatment. In this case, the equilibrium points are this, okay? Under these situations, the equilibrium point equal to this. Then as usual, okay, as usual, and then in the second case also, these are the equilibrium point equation of this. And when Ct equal to 0, that in that case we have that 3 by 3 matrix, as you know that the bifurcation theory, and as you know that the eigenvalues, eigenvectors play very important role in the applied science or applied mathematics. And therefore we consider the Jacobian here, and from the Jacobian we consider the eigenvalues, okay? We consider the different eigenvalues, lambda 1, 1, lambda 1, 2, and so on here, different eigenvalues. And on the basis of the eigenvalues, and as you know that there are a lot of different theorems on the stability and the applied mathematics, okay, in the applied mathematics. And normally when a system is considered, but normal thing is that if it is a one-dimensional case, we consider the derivative, okay, consider derivative, and then at the eigenvalues equilibrium point, we evaluate the eigen derivative, and if the absolute values is less than 1, stable condition, if it is greater than 1, unstable condition, and if it is equal to plus 1, minus 1, if it gives the bifurcations, okay, mid-tail bifurcation, something like this. And therefore, when you consider two-dimensional, three-dimensional case, in that case we find the eigenvalues. If the absolute values of all the eigenvalues less than 1, stable situation. If the one of the eigenvalues, at least one of the eigenvalues greater than 1, in that case unstable condition. And for this purpose, we need to find the eigenvalues, eigenvectors, and the complicated and very important theory regarding the eigenvalues, eigenvectors. But as far as the nonlinear equation is considered here, but nowadays the stochastic differential equation, Dirichlet differential equations, or some other differential equation, if you consider that, in this case it is very, very difficult to find the eigenvalues, eigenvector characteristic equation of theirs. But in that case, as you know, there are a lot of other theorems and results with the help of which also we can say under what condition equilibrium point stable and unstable. And these are the other things, other directions developed as far as mathematics is concerned. And therefore, what is our first theorem there in that case? The healthy equilibrium point E1 star is locally asymptotically stable. Locally asymptotically stable if alpha 1 less than gamma 2 tau delta 1 gamma 3, and unstable if alpha 1 greater than equal to this. And therefore our result says that if these conditions hold, then healthy equilibrium point will be stable. That means if this condition holds regarding the some parameters, in that case treatment is not necessary. The cancer disease will be automatically killed. Okay, cancer disease will be automatically killed. And therefore, this is the one condition here. But if it is greater than this, then in that case, the treatment is necessary. Whether it is the chemotherapy or surgery or whatever the treatment is necessary. And therefore, it is not that a person is suffering from the cancer disease and immediately you start the chemotherapy or surgery or something like this. And if you know how to calculate the parameters, then in that case our theory says that up to these portions, it will be stable. And it is a locally asymptotically stable, that means if the cancer is start from in a particular place, particular part of the body, and in that case under what condition it will be stable. And local stability means starting particular regions, if you try to orbit of this and this point, and that moves to the equilibrium point after t goes 1, 2, 3 of infinity something like that. And when you speak of the global stability we should consider, we need to necessarily to study if the cancer suppose spread over the all bodies, okay? There are a lot of different places of the body where the cancer cell is start. And global stability means whatever may be the initial point, arbitrary point, again it converges to the stability, equilibrium point. And in that case, we can say that under that condition, the stability occurs, or we get the stability. And if you consider any arbitrary point, and that is the, I think, starting of the chaos theory, the initialization point, okay, initial point. How we consider the boundary values, how we consider the initial values, and these are the very challenging. So, what will be our boundary regions, what will be our initial values, and there's a lot of problems, a lot of sophisticated mathematics in this regard. And then what will happen there? And if this condition of our results is that if this condition holds, then in that case it will be stable. Stable means That means no treatment is necessary. And when it will be greater than equal to this, in that case, treatment is necessary. And then we apply some mathematical formula, and applying the mathematical formula, okay, and in that case, we have deduced this formula here. What is the theorem 3? The coexisting equilibrium on E2 stars, with there is a cancer cell is locally asymptotically stable if A11 greater than 0, A11 greater than 0, where A1 equal to and this equal to this here. And regarding the second equilibrium point, it will be stable if this condition holds. It will be unstable if this condition does not hold. Okay. And therefore there are a lot of proof is there, lot of calculation is there. Okay. I do not want to give explain the proof of this. Lot of mathematics is there and something like this. And then regarding the stability, as you know that one is the Rod-Hardwick stability criteria. Okay, that normal things does not work most of the things. That eigenvalue less than 1, eigenvalue greater than 1. Because if there is a suppose 10 by 10 matrix or suppose bigger and bigger matrix, you can calculate the eigenvalues up to 3 by 3 matrix, 4 by. If it is a 10 by 10 matrix, or it is suppose more than that with the data 100 by 100 matrix, manually you cannot find the eigenvalues or eigenvectors. You need the computer technology, you need the computer software. But without finding the eigenvalues and eigenvector, how you can determine the stability? And therefore necessary is the matter of invention. Therefore mathematician has developed a lot of other theories. One of the important theories is the Rod-Hardwick stability criteria. And by applying this theory, we can say that if this condition hold, and in that case the stability occurs, and if this condition does not hold, that in that case treatment is necessary. This is the idea of the mathematics here. Okay, my dear students, I am addressing the students. Are you getting any interest, or you are feeling very bored? Please try to understand that how with the help of the mathematics we can study not only the cancer disease, any kind of disease. Whether it is a heart problem, whether it is a kidney problem, whether your brain problems, and everything can be discussed nowadays with the help of the mathematics of our math. Modeling means not a collection of some differential equation or something. There are a lot of other mathematics coming together, and later on you will see that how artificial intelligence is nowadays applied in dynamics, and the basis of the artificial intelligence behind. There are a lot of data science of mathematical formula involved here. And therefore I think that our Dean Madam is there, Rita Sotri, all the mathematicians are there. If possible in the Royal Global University, there should be a very research center, strong research center, or multidisciplinary, interdisciplinary, and pluridisciplinary. And so that engineering, medical, scientists, different branches of can come together at Royal Global University, and they can do very good research work with the multidisciplinary concept. And the centers might be equal to suppose Ramanujan International Research Centers, okay? We can do that, and that is the objective. And you can establish very strongly a research international level center with a very sophisticated laboratory as well. That bioscience, chemistry, physics, everywhere there is a very strong national level laboratory, not a very weak laboratory. And in that case, you will see that Royal Global University will get the A++ from now. Okay, that is the basic needs nowadays. Okay, basic needs of this. Not only just collection of data or percentage of some data. What is that? You have to go with the modern development of the science and technology as well. And then what is our next study? I am going very quickly because so that I can finish in time. Okay, because in order to discuss a lot of things and lot of mathematics, it will take minimum 3 hours. Okay, minimum 3 hours. And then we can finish that, otherwise not. And when CT is not equal to 0, in the CT is not equal to 0 means the cancer, that means the cancer cells and other things cannot be controlled by the immune system of the body. Immune cell, normal cells fail to kill the cancer cells and so on here, okay? So on here. And therefore, in that case, what will happen is that if you go on this way, okay, if you go on this way, again in that case, again we consider in that case the 4 variables, 4 by 4 matrices, and again we consider the eigenvalues, and this, okay, I can value, and then you see that the tumor pre-equilibrium point is locally asymptotically stable if this condition and this condition so hold. But in that case, we consider E2 with the cancer cell as a deer, and in that case, these are the sum of the discussion under what condition it will be stable, under what condition it will be unstable here, okay? These are the sum of the result here. Okay, these are the lot of calculations of that, okay? And then I do not to discuss this. And this is the concept of the localized stability. And as far as the stability analysis of the global stability analysis, and that is very important regarding the equilibrium point in the treatment case. That means global stability is considered very important when the cancer spread all over the body, when it is the suppose stage 3 or the stage 4 cancer. And that is very important. That in that case, the healthy equilibrium point E1 is locally asymptotically stable inside the positive quadrant of the plate, and it will be globally asymptotically stable in that regions if all this in condition local stability, it must satisfy this condition. That in that case, okay, that in that case it will be also globally stable, okay. If this condition is satisfied, it will be globally stable, okay. And therefore the tumor pre-equilibrium point E1 must satisfy the local stability condition in addition to this derived condition to become the globally stable. And in the next section, we formulate the problem of determining the most effective treatment regimen after we administer chemotherapy treatment at a specific time. And this has been achieved by formulating the corresponding optimal control problems. And therefore, suppose what will happen there, that unhealthy equilibrium, when there is a cancer cell is there, and it will spread over the body, that in that case, that we have to think about this, so that the chemotherapy or any treatment has a very minimum numbers of side effects. Or when the period will be the smaller and smaller, in that case, if you give the chemotherapy 1 dose today after 7 days, and after 7 days, after 1 month, and the health condition become very much deteriorating, very much serious in that case. When the time period can be smallest and smallest, smaller and smaller, we can make. And how we can reduce the dose amount of chemotherapy and so on. And that very challenging mathematical idea. And control theorem, the optimal control theorem, originally it was suppose generated in the economics or financial things here. And optimal control theory, if you consider, notice what I mean is that if in optimal control theory, simulation theory, all this should be a part of our chemistry course. Because optimal control theory itself is a very big research area. And it is not so easy also to understand lot of complicated things are there in optimal control theory. And in that case, regarding the optimal control theory, you see that it is a very challenging thing. And in the optimal control theory, what is that? To make the treatment regimen better, it is expected that the amount of chemotherapy drug dose should be reduced when the size of the tumor gets smaller, as it can save the patient from the attack of the other opportunistic diseases which may take place due to the further decrease in the immune and normal cell. Chemotherapy means longer and longer period means the number of immune cell, normal cell are reducing, and in that case health becomes weaker and weaker, and when the health becomes weaker and weaker, then other diseases attack the body, and ultimately, okay, therefore we propose an analysis the optimal control problem applicable to the model is. Mathematically, we assume that maximum amount of drug is given when the number of tumor cells are high, and it is gradually reduced to 0 with the decrease in number of tumor cells within a prescribed treatment interval 0 Tn. When the time period can be minimized, when the drug dose will be minimized, but output will be optimal, output must be the maximum. That way, all the cancer cell must be destroyed. Okay? For acid cell, we assume that chemotherapy drug in equations of the model as a function of time, high T, and consider it as a control input here. And therefore the chemotherapy drug is given today, normally our, that Guwahati, that cancer cell. And as you know that there are 9 cancer hospitals in Assam here, and I visited some number of cancer hospitals, and I consulted with the doctor here, and doctor simply said that, our surgeons or our expert suggested that chemotherapy group 3 days, 4 days or 5 days, something like this, and accordingly we do. But there is no other calculation or nothing else here. But if every 3 days, instead of every 3 days, whether after 1 day or after 2 days chemotherapy can be injected, how the time can be calculated? And in that case, mathematical calculation is necessary. Because more longer time means more damage of the body. Okay? And that's why the time cannot be a fixed time. That every 7 days you give the chemotherapy, or after 1 month you get a chemotherapy. Time cannot be fixed. The time should be a variable of the control input with the drug. How the drugs reduces the number of cancer cells and so on here. That in that case, I think everybody has some idea of the control theory. And the control theory in that case, what you consider that under this above concept, the objective function of which is to be minimized. That means phi, omega phi equal to 0 to t between beta 1 k, beta 2 I, beta 3. And this is one of the standard formula of the optimal control here. And there are 2 things are there, how the dose can be reduced, how the time period can be reduced, but at the same time, outcome will be the maximum. Okay? Complete cure means that all the cancer cells must be destroyed. Okay? That is the things. And what is in that equation where beta 1, beta 2, beta 4 are the non-negative constant? It should be mentioned that beta I represent the weight factors of the objective function and are used for balancing the size of the curve. The optimal combinations of the control variable phi will be adequate to minimize the tumor density, to negative side effect over a fixed time. The first 3 terms of the integrand functions are the total numbers of the tumor cell, immune cell, normal cell. The 4 terms of the integrand shows the effect of the chemotherapy on the body. And here we have used the problem of optimal control for the model to reduce the burden of tumor cell while maximizing the number of immune normal cells to reduce the time for recovery of the patient, which can reduce the side effect due to lesser amount of chemotherapy in a hospital. And therefore, in optimal control theory, what is the objective? When time can be minimized, at the same time, tumor cell death also maximum. And when there is smaller and smaller time, then at the same time, immune cell and normal cell grow also much away, bigger way. And so that they can fight with the cancer cell as well here. And therefore, in order to that, how we can that ultimately the chemotherapy dose should go to the zero amount, but at the same time complete cure of the patients. And therefore, we consider the omega phi star equal to minimum omega phi, and we consider that in which case, and it will be measurable here. And then we consider, that equations, under this situation, we consider the original equation this and this, with an initial condition of this equal to C1 here, this equal to C1 here, Then in the subsections, the existence of the optimal control of the system is discussed, and the property of super solutions, I bar, K bar, H by C bar, super solutions. When you suppose that the super solution means when the cancer cell become also highest, immune cell also the highest position, and in that case normal cell highest position, and the C bar also the maximum amount what we need to give the treatment of the patient. And in that case, the equation can be under this situation when it will be I bar, K bar, the equation can be reduced this, this means here. Then in that case we consider that, in that case we first show that, and this equation will be bounded. It cannot be that infinite. It must be bounded here. And then again we consider metric equations. The metric equation, these are the variable here, this is transpose, and this is the coefficient matrix of this 4 equation, and these are the parameter I bar, K bar, H bar, and the right hand side constant tau 0, 0, 0, and 5 here. 5 here. And therefore, in the optimal control theory, what is another thing is that by considering the numbers in the first rows of the column or second rows of the column or finding the values of this here, we can, by applying some sophisticated theory, we can discuss the stability of the function and so on here. And therefore, we consider this way, okay, that is that since it is a linear system with bounded coefficients and the time limit is limited, we conclude that super solution I bar, K bar, H bar, C bar of the above system are uniformly bounded. And when there is a common upper bound of a system, in that case the least upper bound exists, and in that case the whole things become very uniformly bounded. And this is the concept of the real analysis. And we found that the admissible control class and the corresponding state equation are non-empty with initial condition given by this. And also by the definition of the set delta, the control set delta is a convex set equation. And there the region, as you know, that everybody has a good idea about the convex set here. And therefore that region, one of the condition, precondition that region must be convex, okay? That region must be convex. I think everybody knows what is a convex set. And it must be closed set as well. The state solutions are bounded, hence the continuity of the right hand side of set system holds and is bounded above by a sum of the bounded control and state. And now we have to show the convexity, okay, that we have proved also that whether it is a convexity or not. Everybody has a good idea about the convexity. And that's first we consider that it is a convex set, and then the region will be valid here. And after that, if we consider under these conditions that objective functionals of these, okay, objective functional, I do not want to discuss a lot of things here. But in that case, in order to find the minimum time period, minimum number of those, but the outcome is this, and in that case, everybody has a good idea. We have to apply the theorems, the quantity maximum principle and the Hamiltonian function. Everybody, I think, applied mathematics, the Hamiltonian function, Lagrange's multiplier, Lagrange's equation. And in that case, we need to apply the Hamiltonian function, and one is the Liouville functions, okay, Liouville functions, and one is the Lagrange's multiplier. And by using all this concept of the Hamiltonian function, and then by applying this theory, we consider the Hamiltonian function this way, with H1i, H2k, H3i, H4c, and that in that case, by substituting the values of I dot means di dt, dx dt, h dot equal to this, by substituting this, and then we have the Hamiltonian equation h1 dot equal to this partial derivative h2 dot equal to this, and this is the h3 dot. Okay, h3 dot equal to this, and then by applying this and consider after, okay, adjoint equation and from the then partially condition are standard result from the Pendegreen maximum principle, and in the case our considered system and adjoint system can be obtained in the form, ultimately it will take the objective function h1 dot h2 dot h3 dot and h4 dot. We have given this idea, and then by using the control theory phi star, and we have got this idea, okay, we have got the phi star equal to h4 twice beta to 0 f this. And these are the bounded things originally considered. Suppose if the cancer cell is maximum, but within a particular regions, and an immune cell also maximum, and we shall give the maximum amount of that also, but in that case the objective function by applying the Hamiltonian system and Lagrange's multiplier, and it has a bounded regions. All these functions will be the bounded regions. And that means this bounded region implies that, whatever the situation of the cancer patients, it can be controlled. And the cancer patients can be completely cured under certain, okay, these conditions, okay. And mathematically we have proved by applying the control theories also, and that it can be completely cured and so on here. And therefore what is our condition? That considering optimal control variable phi star, and a corresponding state variable this and this, there exists ongoing specific adjoint variable h. This is going to satisfy the following conditions of this. And then we get the phi star equal to minimum or maximum of this number here. And as you know that when a sequence or subfunction has a lower bound, it has the greatest lower bound exists. Okay, that means the phi star can be reduced, time can be reduced. Okay, those can be reduced, and these are the what I mean that very but I do not mean according to very sophisticated, powerful idea of the applied science and applied mathematics. We need to study the optimal control theory. But at the same time, the computer software, very sophisticated computer software is necessary. Okay, necessary. And then after that, one of the challenging thing is that when there are a lot of parameters, what will be the range? How we can determine the parameter range? In what case the range will be different? That is very important. It depends upon from country to country. It depends upon from place to place. And in that case, I think in that case with the data science, we have to apply the concept of data science and application of data science. And then the study says that the constant source of rate of the immune cells is the data 0.05 maximum data, and that the range lies between 0 and this. And natural death rate of the immune cell, this and this. This is also very powerful and challenging study, how we can determine the range of the parameter, and on the basis of the parameter, how we can compose the mathematical model. That is also some of the idea. And there are a lot of parameters we need to consider: intrinsic tumor growth rate, the growth of the normal cell, the tumor population carrying capacity, the natural decay rate of the drug, immune cell kill rate of the drug, and so on. So there are a lot of supposed parameters, and what will be the range of the parameter, and these are the upper range of the parameter. Okay, and that is one of the things here. And how do you develop the different theorems? By applying the mathematical formula. We have got some conditions under which the cancer can be cured, under which the cancer cannot be stabilized here, under what condition the treatment is necessary, under what condition treatment is not necessary. But whether these results are correct or not, or to some extent, to what extent it is correct, in that case we need to think the simulation theory. And simulation theory and optimal control theory, students try to understand that these are the very challenging area, okay, in mathematics nowadays. Okay? And if you think of the machine learning, if you think of the artificial intelligence nowadays, and all these are related to each other. And then we apply the simulation theory. And let us have to consider the equation, our modeling. And let us consider our conditions, alpha 1 equal to this condition or this. And in that case, the time variable suppose vary. Suppose 1, 2, 3, 4 vary for a particular time variable, because time cannot be infinite here. Treatment must be within very time period. And if you get the growth of the immune cells, okay, growth of the immune cell, and then initially there are a lot of fluctuations, and after that it will converge, okay? It cannot come to the zero, it will converge. That means if this condition is satisfied, an immune cell is sufficiently strong, that means. Our graph says that the immune cell is sufficiently strong. And in case of the, if you consider tumor cell here, and the time period is giving, and initially there is a fluctuations for different initial values, and ultimately it will converge and come to the horizon, it touches the horizontal axis. That means if this condition is satisfied, cancer cells may be completely destroyed. Come to the horizontal line means it is completely destroyed under this condition. Our graph says. And it is the normal cells and the time, and normal cells go up. When the cancer cells come to zero, normal cell growth becomes high. And therefore our graph says that under this condition, okay, under these conditions, okay, the cancer cells can be completely controlled here. When alpha 1 greater than equal to this condition, alpha 1 greater than equal to this condition, and then regarding the immune cells, and then immune cells grow and grow, and it cannot become to the zero, because immune cell cannot be zero, normal cell cannot be zero. In that case, person will die. There should be at least to some extent. That cancer also converges and remains some amount of this. But in that case, tumor cells also fluctuating initially, and it also stays remain this converges means it cannot come to the zero. That means if this condition holds, the cancer cells cannot be completely destroyed. And in that case, that means treatment is necessary. Our graph also shows that, our numerical simulation shows that in that case, the tumor cells cannot come to the zero, And normal cell also remain to some extent. Immune cell is there, because immune cell, normal cells are the very vital cells for maintaining the normal health of our body. And there are other cells also, that is the case. And therefore, if this condition is satisfied, our graph also says that in that case, cancer cells cannot be destroyed here, okay? Cannot be destroyed here. And regarding the file, that means optimal functions, optimal control function, we give the different values of this initial value, different values of this. In that case, that emotional graph, it also converts, it cannot come to the zero, remains some stable. And the normal cell also, it removes some stables. And if different control parameter, the tumor cells try to touch the horizontal axis, that means number of tumor cells also goes to the zero here. Okay, zero here. And therefore, in our case, if we consider the minimum time, and if you reduce the dose of the chemotherapy dose, and in that case also, that cancer cells can be completely destroyed. Our graph also shows that it touches the horizontal axis and so on here. And therefore, in the vector field, the different conditions here, that in yellow is 0, if you call the initial value, red is represent the initial value, green represent the blue equal to represent this. And initially, our immune cell, our normal cell, our cancer cells, they are trying to grow higher and higher in there. But by applying the optimal control theory, ultimately time can be reduced, it go up, and ultimately it go down. That means time can be reduced, dose can be reduced, something like this. And therefore, these are the some sort of strategy, or some of what we have discussed theory, what we have established the results, and this result is true or not can be verified with the help of the simulation theory, and so on here. These are the different graph of this. And I explained some of these, and I think a lot of other things can be discussed, that how the same cells can be developed inside the tumor cell. And as you notice, these are the data we have calculated, or our mathematicians have calculated by the average of the per day, okay? By the average of the per day, that is. But nowadays, scientists have found that what is the mathematics play so much important role of that in that case, you will see that not a unit, not the parameter per day, it must be calculated with a very smaller and smaller and smaller unit. And as you know that the last year, the 2023 Nobel Prize was won by the chemistry quantum dot. What is the quantum dot? What is the size of the quantum? So smallest. And then in physics, they try to find the activities of the light and electron by using the attosecond. Attosecond means 10 to the power minus of 1 second. So small unit, small unit. And now the question is that everything must be calculated with a very smallest and smallest unit here, not a second, not a day. And that is one of the challenging things, and that's why scientists also say that in order to do very sophisticated research in the science and technology, the quantum computer is necessary. And this laptop computer will not do sufficiently. And therefore we need the quantum, why we need the quantum of this. And what is the reason behind that, the quantum concept, quantum mechanics, quantum chemistry, quantum mechanics, or even quantum mathematics, that the normal human cell, it is just like an oval type, circular or elliptic type. But the structures of the cancer cell are highly complicated, not the oval, not something, highly complicated. When the structure is very complicated, in that case, we need to find out what is the size, what is the volumes, what is the surface area of the cancer cell, and in that case, we need to apply the fractal geometry concept. Fractal geometry gives the tools and method how to determine the surface area volume of a very complicated structures of this. And this way we can do a lot of mathematical thing in the different cancer diseases and so on. And sorry, I am taking a lot of time, so thank you very much for the question, hearing, and your kind cooperation.
Thank you, sir.
And